All right, what we're going to cover here is basically a modification I did to this DP-63A. It had a broken meter, okay? So I elected to get, obviously, a brand new meter, which was available. A brand new meter was available. And pretty much the same as the one that was in there with a few minor differences. So went ahead, got the meter, and I wanted to make it look very similar to the electroluminescent one. And what I ended up doing was ordering these LEDs. And let me tell you, they're very, very thin wire on these things. It will stress you out trying to strip this wire. There is no doubt you will get stressed out unless you happen to have super small stripping devices. But these things are incredibly tiny. And look, I mean, it's got a pretty good angle of the distribution of light. I only needed one of these installed in here, right? Look at that. I'm just holding it above it, and you can see how much it actually fluoresces. This is a 3D printed piece of plastic printed with some filament that's UV reactive. The print file, I may have access to that. If I do at some point, I'll link that and also link these LEDs. It comes with a pack of 20, so if you mess up stripping them, they got plenty to gain some experience on. And I'll try to link that when it's available. The batteries for the device, it was in this pack. I don't know what it was branded as before, but basically the batteries that are in it fit pretty well inside the unit. And I simply used a spring underneath the battery over here to make up, because the contact is a bit recessed inside the housing. So a spring of the appropriate size and length works fine for that, because you don't want to over tighten this. This already had a slight cant upwards to it because somebody over tightened it. So no need to over tighten this when you do it that way. So that's how the batteries are being accounted for. And this functions the same way as an electroluminescent one would function. Basically, here's your test function, battery check, the needle deflects properly. This is the low range function. This is the high range function. Now, don't be concerned about how bright this is here. That's the camera. It's overexposing it. It doesn't look anything like that in real life. It looks more like what I showed you when I held the LED above it, pretty much, with a bright spot in the center there. And that can vary too, wherever you put that LED. So basically, those are the parts. Now you say to yourself, where am I going to tap off? And I'll open it up in a minute and show you, but best place to start is with your schematic. And this is the schematic for this instrument. Basically, the positive was very simple. I'll show you when I open it up where I came off the positive battery connector inside the device. So that goes over to the LED, okay? To the positive side of the LED, the UV LED. The negative side, because you want to make it work with the original switches, okay? These switches here, you got to figure out where you're going to tap off for that negative. And you don't want to do it on a component, right? Because you don't want to draw down too much current. I know the LED doesn't use much at all, but anyway, you want to stick away from the component. And there's a wire in there that comes off this switch. They're going to be those green wires. You're going to have to verify you're at the right point. And you're going to have to carefully strip back the insulation and part of that wire, and then you'll see how I did it inside, and attach your negative lead, come off of that, and your negative lead is going to come back over to the other side of the LED. That's where and how we got power and maintain the original function of the illumination, the backlit illumination of the meter, using the original switches on the device. Again, there you go there, and there. Again, each switch operates that backlight just well. All right, so let's go take it apart. I already had it loose. And what you've got in here is these green wires here. They come from these switches over here, right? That was the ones on the schematic. And I tapped in right here, all right? That's how I did it, all right? And the reason for the difference in this length of wires, because by the time I stripped one of them, I ended up losing a couple inches, but it's fine. I laid the wire in this electrical tape here just to give it a little extra protection, because the insulation that's on this wire is very thin. And I can't emphasize enough, these wires are extremely thin. They're like something you use in your model railroading or Lego kits or whatever, but they're very thin and very pain in the butt to strip. And like I said, it will stress you out. This is a bit cold on the soldering joint here, I know, but I really don't care. because what I did is I took a solderless connector, loosened this nut, right? Placed a solderless connector on it with the wire, the positive wire, soldered to it, all right? So that's where I'm getting the positive from, comes back down, all the way back down to the LED, which is kept in place by nothing more than this material. This is actually vacuum seal tape. You can get this on Amazon, or you can use whatever you think will do the same thing. It's just something to keep, it's got tackiness to it, so it stays in place and keeps the LED from moving. Because basically I place the LED in between the little clamp here, right? That's the normal clamp that goes on the, what would normally be either the electroluminescent display or a radium piece that would be in there. And it just slips basically under that in the center of it, okay? That component's still there. But basically, yeah, that's how you can take, if you don't have the backlit feature on this, this can be done to either, I'm assuming, the electroluminescent or the old radium ones, eliminating that hazard of the radium backlit piece in there. Okay, so basically, yeah, that's how I did it. It worked out great, and keeps a lot of the same aesthetics of the instrument by doing it this way. And you just need to be careful when you put everything back together that you don't pinch those little tiny little wires that are in there on the device. And there you go. So you'll have a fully operational, as would normally have been originally on the instrument, using the buttons provided on the instrument. Again, I'll try linking some of these parts at some point. I don't have all that information yet, but I figured I'd just share this now for those of you that are thinking of actually doing a modification on yours, to show you how I did it, okay? All right.